synchronous counter. So ring counter and the Johnson counter is considered as a examples of your synchronous counter. Now in this case, ring counter. So what is meaning of ring counter? Now observe this circuit diagram. In that particular circuit diagram, see, a D type of flip-flop is considered because what happen, a ring counter is also called as a shift register, circular shift register, with only one flip-flop being set at any particular time and all others are clear. Okay, so first understand it is a shift register. So for designing, with the role of your ring counter is just shift the data from one flip-flop to another flip-flop. So it is also called as a register. But in this case, if you observe that this is the examples of your synchronous counter. So a common clock pulse is considered here. This is a common clock pulse is considered and it is applied to each and every flip flop. Okay. So this circuit is called as a synchronous circuit. If it is output of your first flip flop is connected as a clock input of next flip flop, then it is called as a asynchronous circuit. Okay, now this is a synchronous circuit. Next thing is what happened in this one, the data is going to just, we want to shift the data. So D flip flop is there. So what is the property of D flip flop? The output value and the input values are same, but it is delayed by one clock pulse. Okay, when you are applying the clock pulse, then and then your output value is just same your input value. So here what happened, the now we want to shift the data. So from one flip flop to another flip flop we want to shift the data. So output of your first flip flop is connected as an input of your next flip flop. See here the output of first flip-flop is connected as a data input of your next flip-flop. In case of asynchronous counter, output of your first flip-flop, it is given as a clock input of your next flip-flop. Don't be confused in between asynchronous counter and the synchronous counter. Okay, simple, you have to keep in your mind what the common clock pulses is applied to each and every flip flop which are connected in the register. Okay, that is called as a synchronous counter. And here the output of your, it is a, if it is a shift register, so output of your first flip flop is connected as a data input of your next flip flop. बोलो ले. Next thing is uh, second flip flop, output of your second flip flop which is connected to the next third flip flop, and the output of your third flip flop it is connected as a input of your fourth flip flop. For example, here we are considering the fourth flip flop. One important thing is why it is called as a ring counter. Okay, because here you can observe that output of your last flip flop, here four flip flop is considered, so output of your fourth flip flop it is given as a input of your first flip flop. Output of your fourth flip flop or the last flip flop, it is connected to the input of first flip flop. That's why it is called as a ring counter. Are you getting? In shift register, what happened in normal shift register? We are not connecting the last flip flop output of your last flip flop. We are taking the output from the last flip flop. But here, the output of your last flip flop it is given to the input of your first flip flop. So clear this thing. Now next important point is why it is called as a ring counter. Now next important point is what happen with only one flip flop is being set at any particular time, all others are clear. Now for that purpose, okay, see here, all, see here, out of these four, three flip flops are connected to the clear pin. Okay, and the one preset pin is connected, only one flip flop preset pin is connected at the starting, because what happened out of these four flip flop, okay, one flip flop pin is, we want to set the output of one flip flop should be a something. Okay, something means it's not a non-zero. Okay, so for understanding purpose I have considered here. Okay, see, suppose if I am not giving the if I am not considering any flip flop is going to be set. Okay, and what happen, all the flip flops having a 0 0 value initially. So what happen when you are applying the clock pulse? Okay, at a time what happen, this 0 will be shifted to this D, this 0 will be shifted to next D, and this 0 will be shifted to this D, and this 0. Now output you are getting this 0 because Q is connected. Okay, so the again 0 will be shifted here. So after first clock pulse, what happen? Your output is 0 0 0. Now suppose if I am applying the next clock pulse, second clock pulse. So what happen? This bit will be shifted here. This bit will be shifted here. This bit will be shifted here. Okay, and this bit will be shifted here. So what happen every time if you are applying the n clock? Okay, so every time what happen, you are getting the same output, that is 0 0 0. That's why there is a limitation in the ring counter, what at least one flip flop you need to be set. Okay, so what happen, for understanding, you can set any flip flop by using this setting. Okay, उसका clear pin आपको connect नहीं करना है. Okay, only preset pin connect करना है, just like this setting. Okay, only this setting you have to do. Okay, and you can set any intermediate flip flop, no problem, but for understanding, just I am considering this flip flop. So when at initially, okay, we are considering this condition, and how the number of clock pulses we are applying, how this data is going to be shifted, we'll see in the next slides. Okay, so the single bit is going to be shifted from one flip flop to the next flip flop to produce the sequence of a timing signal. Okay, so here consider initially at 0th clock pulse, I'm considering this condition 1 0 0 0. Now suppose I'm applying the first clock pulse, then I'm getting the output like this bit will be shifted here in this way. Okay, then this bit will be shifted here, then next bit will be shifted here, and last bit, that is Q3. Okay, it is coming to here. Okay, Q3 is coming to here because of due to a feedback connection. Then in second clock pulse, this bit will be shifted here, then this one will be shifted here, this 0 will be shifted here, and now this Q3 will be shifted here. Okay, now next 0 will be shifted here, this 0 will be shifted here, this 0 will be shifted here. Now this is Q3. Now the Q3 value is 1, so the 1 will be shifted here. Okay, so what happened, if you observe that, okay, the after fourth clock pulse, clock pulse, your sequence is going to be repeated. Your sequence is going to be repeated in the ring counter. Now again, it depends on how many flip flops are connected. If it is 8 flip flops are connected, then after 8 clock pulse, your sequence is going to be repeated. If 6 flip flops are connected, then after 6 clock pulse, your sequence is going to be repeated. So n, here we can say that n flip flops, n clock pulse you require to repeat the same sequence, or to repeat the initial sequence. Clear? Now this is just a timing diagram, okay, for this ring counter.